Guys, can you hear me? All right. Good evening, and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great. So, people, quickly let me know in the chats if you all can hear me. Let me know quickly in the chats. Let me know quickly in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Quickly, people, let me know in the chats. Where did I keep my water bottle? Just a second, guys. Just a second. I'm sorry. Just a second. All right. So, can you tell me how many of you are done with the yesterday's session? Yesterday, I have taken one session, top 50 concepts part 1, and today it's part 2. So let me know once in the chats. I just want to know how many of you are done with the yesterday's session, people. I just want to know that. I just want to know that first. Okay, got it. Got it. All right, so my dear students, today it's going to be again the top 50 concepts part 2, right? The duration of the session is going to be 1.5 hours, right? In 1.5 hours, I'll try to complete almost like 15 more concepts. How many concepts we did yesterday? Can you tell me in the chats once? How many concepts we did yesterday? How many concepts we did yesterday? I am asking you. Some 12 concepts, right? Today we shall be doing 15 more concepts, my dear students. Or maybe 16 more concepts. 15 or 16 more concepts we shall be discussing in the today's session. And one thing I'm going to assure you, in the upcoming Re-NEET examination, you will find questions directly or indirectly from these sessions, for sure. That's my assurance to you. So watch these sessions till the end and follow them properly. Okay? And people, few minutes back, I have posted one video also. The last 10 days, what you are supposed to do, to watch that particular video as well after this live session. Okay? Hello, guys. Let's get going. Let's get started with the today's session. And you know, before starting the session, I would want to know which part of the country you guys are watching me from. I just want to know that first. Duration of today's session will be almost 1.5 hours. Something around that. 1 to 1.5 hours. Don't worry. I just want to know which part of the country you guys are watching me from. Okay, so I can see people from Andhra Pradesh, Karnataka, West Bengal, Tamil Nadu, Kerala, Jammu, Pondicherry, Andhra Pradesh, Kerala, AP, Tamil Nadu, Karnataka, New Delhi, Shillong, Kashmir. Okay, Chhattisgarh, Gujarat. All right. Perfect, guys. Got it. Maharashtra and Mizoram, Hyderabad, Jharkhand, Saudi. Nice. All right. Perfect. Got it. UP, Delhi, Kerala, Tamil Nadu. Okay. Leave it. Got it. I got it. Till now. So should we start the session? Give me some fire emojis in the chats quick. Should we start the session, people? Give me some fire emojis in the chats, every one of you. Quickly in the chats. Perfect. Chalo, let's get going with the first concept of the today's session. And the first concept is, how do we draw the Lewis structures? How do we draw the Lewis structures? The topic is from the chapter Chemical Bonding. How do we draw the Lewis structures? That is going to be the first concept which I shall be discussing in the today's session. A very simple and basic concept, provided you keep an eye on the screen properly. Now understand, people, what I'll be doing. For example, let me take a molecule, carbon monoxide. I am selecting a molecule here as carbon monoxide. I want to draw the Lewis structure of carbon monoxide. CO. My dear students, how do I draw the Lewis structure of carbon monoxide? There are few things which you need to take into consideration. And what are those things which you need to take into consideration? Try to have a look. First of all, if I ask you, how many valence electrons carbon has? The answer is going to be 4. How many valence electrons oxygen has? The answer is going to be 6. So 4 plus 6 makes it 10. Valence electrons with carbon are 4. Valence electrons with oxygen are 6. So in total, how many valence electrons do we have? We have got 10 valence electrons. My dear students, 10 valence electrons means how many valence electron pairs? I'll say 5 valence electron pairs, right? Because one pair consists of 2 electrons. Right? So I've got in total 5 valence electron pairs. Now what I'll be doing, this is your carbon, this is your oxygen. The first thing which you'll be doing, you'll put a single bond. Put a single bond first. Single bond means I've used 1 electron pair. How many electron pairs I have in total? 5. Out of 5, how many I've used? I've used 1 electron pair. So there are 4 valence electron pairs left. Now, do one thing. Select the more electronegative element, that is oxygen. Start filling the octet of this oxygen. So, I'll say 1, 2, 3, 4, 5, 6, and these 2 are 7, 8. Octet of this oxygen is complete. How many valence electron pairs I had? 5. Out of 5, how many I have used? This is first pair, second pair, third pair, fourth pair. So there is 1 valence electron pair left. Give that electron pair to carbon. Okay. Now, if I ask you, have I utilized all the 5 valence electron pairs? I've utilized all the 5 valence electron pairs. Is the octet of oxygen complete? Yes, the octet of oxygen is complete. But is the octet of carbon complete? Check that out. Well, if you look carefully, carbon has got 1, 2, and 3, 4. Only 4 electron pairs here. Only 4 electrons here. The octet of carbon is not complete. So what are we supposed to do? Remove 1 of the electron pair from oxygen, and instead of that, put a bond. Remove 1 more electron pair from oxygen. And instead of that, put a bond. Now, my dear students, do check the octet of both the atoms. First of all, check the octet of oxygen. 1, 2, 3, 4, 5, 6, 7, 8. Completed. 1, 2, 3, 4, 5, 6, 7, 8. Completed. So octet of both atoms is completed. So this is your Lewis structure of CO, which is your carbon monoxide. Okay. I believe this is clear to everyone. Yes. Let me take one more example. People. Let's say you have got Cn negative. You want to draw the Lewis structure of this particular molecule, Cn negative. First of all, what I'll be doing? My first step is calculate the valence electrons. How many valence electrons carbon has? 4. How many valence electrons nitrogen has? 5. There is a negative charge, so add it. So 5 plus 1 is 6, 6 plus 4 is 10. So in total, there are 10 valence electrons. 10 valence electrons means how many valence electron pairs? 5 valence electron pairs. 10 valence electrons means 5 valence electron pairs. Now what I'll be doing? This is your carbon, this is your nitrogen. Put a single bond. That means 1 electron pair I've used. How many I have in total? 5. Out of 5, I've used 1. So 4 electron pairs are still left. Now start filling the octet of more electronegative element. Which one is more electronegative? Nitrogen. So 1, 2, 3, 4, 5, 6, 7, 8. Octet of nitrogen is complete. How many electron pairs I had? 5. Out of 5, how many I've used? 1, 2, 3, 4. And put 1 on this particular carbon. Now if I ask you, since the octet of nitrogen is complete, is the octet of carbon complete? Octet of carbon is not complete. So try filling the octet of carbon. How exactly? Remove one of the electron pair from nitrogen and put a bond. Remove one more electron pair from nitrogen, put one more bond. Now check the octet of both the atoms. 1, 2, 3, 4, 5, 6, 7, 8. Completed. 1, 2, 3, 4, 5, 6, 7, 8. Completed. So this is your Lewis structure of Cn negative. I believe I'm clear with this. Yes, I believe I'm clear with this. If yes, let me know once in the chats. Let me take one more example. With that, things will be more clear. For example, I'm writing CO3 dinegative. CO3 dinegative. I want to draw the Lewis structure of this particular species. CO3 dinegative. Okay. What is the first thing which I'll be doing? Calculate the valence electrons. You know, carbon has got 4 valence electrons. Oxygen has got 6 valence electrons. And there are 3 oxygen atoms multiplied by 3. And there is a negative charge. So add this negative charge here. Add this negative charge here. So how many valence electrons I'll be getting? 6 3s are 18. 18 plus 2 is 20. 20 plus 4 is 24. So in total, there are 24 valence electrons. 24 valence electrons means how many valence electron pairs? 12 valence electron. 12 valence electron pairs. 12 valence electron pairs. Okay. Now, my dear students, what I'll be doing? If this is carbon, let this be oxygen, let this be oxygen, let this be one more oxygen. So put 3 bonds here. So 3 electron pairs I've used. Now start filling the octet of more electronegative element. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So how many valence electron pairs I had? 12. Out of 12, how many I've used? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So all the 12 valence electron pairs I've used. Now, octet of all the 3 oxygens is complete, but the octet of carbon is not complete. The octet of carbon is not complete. So what am I supposed to do? Select any of the oxygen, remove one of the electron pairs, and instead of electron pair, put a double bond. Now, the octet of all the atoms is complete. Check this out. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Done. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So octet of everything is completed. Right? So this is the structure of your CO3 dinegative. Perfect. This was your concept number 1. Now, I believe you can easily draw the Lewis structures of these simple molecules which are asked in the examination. Say yes or no once in the chats if this is clear. Every one of you. Say yes or no once in the chats quickly, people. And I can see all the students have not liked the session yet. And you know, liking the session is mandatory. So I would highly recommend all of you to smash the like so that everyone gets benefited out of these sessions, so that these particular sessions reach maximum audience. Quick. Perfect. My dear students, let me move on to the concept number 2. What is my concept number 2? That is, how do we calculate the formal charge on different atoms? How do I calculate? Sir, please do little speed up. You don't worry about my speed. I told you I'll be discussing 15 concepts in 1.5 hours. Okay? So do not interfere, please. Okay? Let me teach the way I teach. I don't want to modify my teaching style, going fast, going slow, just because of some. Okay. Can we move on? If you have got some work, you can watch the session in the recorded format at 1.5x. Okay? Chalo guys, second concept is how do we calculate the formal charge? How do we calculate the formal charge? My dear students, in order to draw the formal charge, in order to write the formal charge, in order to calculate the formal charge on all the atoms, in order to calculate formal charge on all the atoms, the first thing which you are supposed to do is you are supposed to draw the Lewis structures. For example, I'm supposed to calculate the formal charge on carbon. I'm supposed to calculate the formal charge on oxygen, right? So first of all, I'll be drawing the Lewis structure. After drawing the Lewis structure, what I'm supposed to do? After drawing the Lewis structure, what I'm supposed to do? Understand very properly what I'll be doing. Okay, understand very properly. My dear students, let's start with carbon monoxide, CO. Let's start with CO molecule. Since we have already drawn its Lewis structure and how the structure looks like, this was C, this was triple bond O, oxygen having a pair of electron, carbon having a pair of electron. This was the structure of your CO. Now I have to calculate formal charge on carbon and I have to calculate formal charge on oxygen. Formal charge on carbon and formal charge on oxygen. How do we calculate the formal charge? Tell me one thing. Carbon in non-bonded state. Carbon in non-bonded state has how many valence electrons? Carbon in non-bonded state will be having 4 valence electrons, right? Carbon in non-bonded state is having 4 valence electrons, okay? Minus. In this structure, how many valence electrons carbon has? Let's check it out. 1, 2, correct? Now, from this bond, take 1 electron. From this bond, take 1 electron. From this bond, take 1 electron. So 1, 2, 3, 4, 5. So 4 minus 5 comes out to be minus 1. So formal charge on this carbon here is minus 1. Okay. Now, what about the formal charge on oxygen? Oxygen in non-bonded state has got 6 valence electrons. Minus. How many it has right now? How do I calculate it? 1, 2. From this bond, select 1. From this bond, select 1. From this bond, select 1. So 1, 2, 3, 4, 5. So 6 minus 5 is plus 1. So you got the formal charges on carbon and formal charge on oxygen. I would say formal charge on carbon is minus 1. Formal charge on oxygen is plus 1. I believe this is clear. Okay. Simple and basic concept this is. For example, you have got Cn negative. I'm asking you to check the formal charge on carbon and nitrogen. First of all, what you have to draw? You have to draw the Lewis structure. And since you have already drawn the Lewis structure, this is C triple bond N and both the atoms having 1 electron pair. This is C triple bond N, this having electron pair, this having electron pair. Right? Now, I'm supposed to calculate formal charge on carbon and at the same time, I'm supposed to calculate formal charge on nitrogen. How do I calculate it? The same thing which I showed you earlier. My dear students, what exactly you are supposed to do? If I talk about carbon, in case of carbon, I must say, in non-bonded state, carbon has 4 valence electrons. Minus. Right now, how many valence electrons carbon has? 1, 2. Take 1 electron, take 1 electron, take 1 electron. 1, 2, 3, 4, 5. So 4 minus 5 is minus 1. Formal charge on this nitrogen. Nitrogen in non-bonded state has got 5 valence electrons. Minus. Right now, how many it has? 1, 2, 3, 4, 5. So 5 minus 5 is 0. So its formal charge here is 0. Okay? Its formal charge here is 0. Perfect. Now similarly, for example, this is the molecule. If I'm asking you what is the formal charge on this oxygen, oxygen has got 6 valence electrons in non-bonded state. Minus right now 1, 2, 3, 4, 5, 6 and 7. So 6 minus 7 is minus 1. So formal charge on this oxygen is minus 1. What about this particular oxygen? Oxygen in non-bonded state, 6 valence electrons. Minus right now 1, 2, 3, 4, 5 and 6. So 6 minus 6 is 0. This oxygen does not have any formal charge. Even this oxygen does not have any formal charge. Is that? No. Let's check it out. If you talk about this particular oxygen, oxygen in non-bonded state, 6 valence electrons, minus right now 1, 2, 3, 4, 5, 6 and 7. So 6 minus 7, here is minus 1. So formal charge on this oxygen here is minus 1. Perfect, people? Perfect. I believe you got to know how do we calculate the formal charge. If yes, let me know once in the chats. If yes, let me know once in the chats. Yes? Perfect. Yes, you can calculate formal charge in case of O3 molecule as well. Just draw its structure and calculate formal charge on each oxygen with the help of the rules which I gave you. That's all. Perfectly done. Why is dipole moment of CH3Cl greater than that of CH3F? Dipole moment only does not depend on the charge on the atoms. It depends on the distance on the atoms as well. Now, CCl bond length is more than that of CF bond length. Therefore, the distance factor dominates here than the charge factor. That is the reason why your CH3Cl has got more dipole moment than that of. Okay, I believe I'm clear. Chalo, moving on. Moving on, people. The third topic from which the question frequently is going to come. What is that? That's your Fajan's rule. That's your Fajan's rules. Where do we use the Fajan's rules and how do we use them? My dear students, you will find a lot of questions wherein you will be given with certain molecules. You will be given with certain molecules and you will have to arrange them on the basis of their covalent character, on the basis of their ionic character. Arrange the following molecules on the basis of covalent character. Arrange the following molecules on the basis of ionic character. Those sort of questions are frequently asked. Now, how do we deal with those sort of questions? Simple and basic stuff. Remember, covalent character. Covalent character in an ionic bond. Covalent character in an ionic bond depends on two parameters. Number one, it is directly proportional to polarizing power. It is directly proportional to polarizing power of what? Polarizing power of cation. Polarizing power of cation. Also, remember the covalent character. Remember the covalent character is directly proportional to the polarizability. Polarizability of what? Polarizability of anion. Polarizability of anion. Now, what is polarizing power? What is polarizability? I've got nothing to do with that right now. Just remember a few things. That's all. Enough to solve the questions. Remember just one thing. Remember just one thing. Polarizing power. Remember just one thing. Polarizing power of the cation. Of the cation is directly proportional to charge on cation. Inversely proportional to the size of cation. Okay. Similarly, my dear students, if you talk about polarizability of the anion, is directly proportional to the charge on anion, also directly proportional to the size of anion. These are few things which you are supposed to remember. That's all. That's enough. More than sufficient. Okay. So more the charge on cation, more the polarizing power of cation, more the polarizing power of cation, more is the covalent character. Similarly, lesser the size of cation, more the polarizing power of cation, more the polarizing power of cation, more the covalent character. Similarly, more the charge on anion, more the polarizability of anion, more the polarizability of anion, more is the covalent character. More the size of anion, more is the polarizability of anion, more the polarizability of anion, more is the covalent character. That's all. Okay. Now, for example, you can take some questions. For example, my dear students, the first question. I've got, let's say, LiCl, right? I've got BeCl2. I've got AlCl3. I'm asking you to give the covalent character order here. I'm asking you to give the covalent character order. You can easily give it. What you have to do exactly? First of all, this is Li positive. This is Cl negative. This is beryllium di positive. This is Cl negative. This is aluminium tri positive. This is Cl negative. Now, Cl negative, Cl negative, Cl negative, everywhere is same. So I am not going to decide on the basis of Cl negative. I am not going to decide on the basis of Cl negative. I'll be deciding on the basis of cation. Right? Li positive, B di positive, Al tri positive. More the charge on cation, more the polarizing power of cation. More polarizing power of cation means more is the covalent character. So this is the order of covalent character. Yes? Simple. Right, people? For example, let's say I've got LiF, NaF, KF, RBF. I'm asking you, what is the order of the covalent character? I'm asking you, what is the order of the covalent character? What is the order of covalent character? Quickly in the chats. Quickly, people in the chats. Again, the question is going to be similar. If you look carefully, this is La positive, this F negative, Na positive, F negative, K positive, F negative, Rb positive, F negative. F negative is everywhere same. So I'm not going to decide on the basis of F negative. I'll be deciding on the basis of cation. I will be deciding on the basis of cation. Now, my dear students, the charge on cation is same. Now decide on the basis of size of cation. Lesser the size of cation, more the polarizing power of cation. More polarizing power means more is the covalent character. As simple as that. Right? For example, BeCl2, MgCl2, CaCl2. Tell me the order of ionic character. This was the order of covalent character. Now I'm asking you to give me the order of ionic character. Remember, whatever will be the order of covalent character, whatever will be the order of covalent character, reverse of that will be the order of ionic character. Reverse of that will be the order of ionic character. So first of all, if you look at the covalent character order, this is Be dipositive, Mg dipositive, Ca dipositive. Lesser the size of cation, more the polarizing power, more the covalent character. More covalent character means lesser ionic character. So this is the order of ionic character here. This is the order of ionic character here. For example, you get a question like this. CuCl and NaCl. Give the order of covalent character. Remember this particular one. Remember this particular one. CuCl has got more covalent character than NaCl. Why is that? Because in case of Cu positive here, you get pseudo inert gas configuration. Just remember it. Cu positive has got pseudo inert gas configuration. Pseudo inert gas configuration. Just remember it directly. Okay, am I clear with this? Am I clear with this, people? I believe these sort of questions you can easily solve, right, when it comes to Pajan's rule. Just remember the slide that I gave you. That's more than sufficient. So this was your concept number 3, and we are done with that. Now, concept number 4. Questions are asked from hybridization as well. Okay? Questions are asked as per hybridization as well. Now, my dear students, how do we calculate hybridization? And how do we check the geometry of the molecule as per hybridization? Let's talk about that now. Let's talk about that now. A simple concept, and will be done in some time only. There is a method, my dear students, of calculating the hybridization. The method is called as steric number. The method is called as steric number method. And what is steric number? Steric number is nothing but it is equal to the number of sigma bonds that the central atom forms, the number of sigma bonds that the central atom forms, plus the lone pairs on the central atom. The number of sigma bonds that the central atom forms, plus the number of lone pairs which the central atom has. What does that mean? What does it mean exactly? I'll let you know in some time. But before that, there are a few more things which I would want to discuss with you. What is that? Remember, when the steric number comes out to be 2, hybridization involved is sp. When the steric number comes out to be 3, hybridization involved is sp2. When the steric number is equal to 4, hybridization involved is equal to sp3. When the steric number is equal to 5, hybridization involved is sp3d. And when the steric number is equal to 6, hybridization involved is sp3d2. And when the steric number is equal to 7, hybridization involved is sp3d3. sp3d3. These are few things which you need to know first of all. Okay? Now people, understand and remember a few more things. There can be a question asked. In sp3d hybridization, which d orbital is involved in hybridization? Remember, it is dz square that is involved in the hybridization here. Which d orbitals are involved in sp3d2? It is going to be dx square minus y square and dz square. And dz square. Similarly, in sp3d3, it's going to be dx square minus y square, comma, dz square and dxy. These are the 3d orbitals which are involved in the hybridization here in case of sp3d3 hybridization. Okay? At the same time, in case of sp hybridization, the geometry involved is linear. sp2, it is trigonal planar. sp3, the geometry involved is tetrahedral, right? sp3d, it is trigonal bipyramidal, right? Similarly, sp3d2, it is octahedral, and here it is pentagonal bipyramidal. Pentagonal bipyramid. Okay? Now the point is, how do we apply all this in the questions? How do we apply all this in the questions? How do we get the hybridization in different molecules? Try to understand what exactly I'll be doing. My dear students, for example, I'm taking the first and the simple molecule as CH4. I want to calculate hybridization of carbon. I want to calculate hybridization of carbon. Tell me how many valence electrons carbon has? You should be knowing carbon has got 4 valence electrons. Carbon has got 4 valence electrons. Now, how many surrounding atoms do you see? 4 surrounding atoms. Remember, number of surrounding atoms is equal to number of sigma bonds. Remember, number of surrounding atoms is equal to number of sigma bonds. Okay? Number of surrounding atoms is equal to number of sigma bonds. Now, this carbon had 4 valence electrons. Carbon had 4 valence electrons. And this carbon is utilizing all the 4 valence electrons to form 4 sigma bonds. Carbon is utilizing all the 4 valence electrons to form 4 sigma bonds. So there will be no lone pair on carbon. No lone pair on carbon. So what would be the steric number? Steric number is sigma plus lone pair, 4 plus 0, 4. When steric number is 4, hybridization will be sp3. So carbon here is sp3 hybridized. Simple. Okay. Now, for example, you have got NH3. I'm starting with simple molecules first. NH3. This is your central atom. How many valence electrons are there with nitrogen? 5. Nitrogen has got 5 valence electrons. Now tell me, how many surrounding atoms do you see? 3 surrounding atoms. That means sigma bonds are 3. I would say out of 5 valence electrons, nitrogen is utilizing all. Out of 5 valence electrons, nitrogen is utilizing 3 valence electrons to form 3 sigma bonds. I would say 2 electrons are left as such on nitrogen in the form of a lone pair. In the form of a lone pair. Now tell me, what would be the steric number? Steric number is again sigma plus lone pair, 3 plus 1, 4. When steric number is 4, hybridization involved will be again sp3. It would be again sp3. I believe this is clear. For example, you have got a species like H3O positive. H3O positive. I'm asking you to calculate hybridization of oxygen. So how many valence electrons do you see here? Oxygen has got 6 valence electrons. But there is positive charge, so subtract it. So 6 minus 1 is 5. Right? How many surrounding atoms do you see? 3. So that means there are 3 sigma bonds. Out of 5, 3 are used. So 2 are still left in the form of a lone pair. So 1 lone pair. Again, steric number is sigma plus lone pair, 4. Hybridization is sp3. Okay. For example, I've got the molecule XCF2. XCF2. Talk about xenon. How many valence electrons xenon has? 8. How many surrounding atoms do you see? 2. How many lone pairs would be there? Out of 8, 2 are used. So 6 are left as such in the form of 3 lone pairs. So steric number, sigma plus lone pair, 3 plus 2, 5. Hybridization, sp3d. sp3d. Okay. Am I clear, people? Tell me one more thing. For example, you have got the molecule like this. I3 negative. I3 negative. I want to know the hybridization of the iodine here. First of all, I3 negative can be written as II2 negative. It can be written as II2 negative. I want to calculate hybridization of this iodine. How many valence electron iodine has? 7. There is a negative charge, so 7 plus 1 makes it 8. How many surrounding atoms? 2 surrounding atoms. So sigma bonds are 2. Out of 8, 2 are used. So 6 are left as such in the form of 3 lone pairs. So lone pairs are 3. Steric number, sigma plus lone pairs, 3 plus 2, 5. Hybridization, sp3d. Am I clear with this? Am I clear with this, people? Am I clear with this? There are few people who need to be blocked right now. And they are blocked. Thank you so much for being the part of the channel. You can go to some other channel now. All right, guys. I believe all of this is like very, very, very clear to you. Okay. So from now onwards, can you check the hybridization easily? Quickly, let me know in the chats. Perfect, guys. So we are done with 4 concepts till now. Now the 5th concept, which is frequently asked. Frequently asked. And I'll be just giving you the trick. I will be just giving you the trick of solving the questions which are based on bond order. First of all, remember one thing. Bond order is directly proportional to bond strength. It is directly proportional to bond strength. Or you can say bond order is directly proportional to bond dissociation energy. Bond dissociation energy. Or you can say bond order is inversely proportional to bond length. So there can be questions asked from bond order, bond strength, bond dissociation energy, or bond length. Okay? Okay? All right. Now understand few more things. There's a trick of calculating the bond order. Okay, and what is that trick? Understand. First of all, whenever you see a 14 electron species, whenever you see a 14 electron species, remember 14 electron species, you'll always find bond order equal to 3. Whenever you see 15 electron species, its bond order you'll find as 2.5. 16 electron species, you'll find its bond order as 2. 17 electron species, its bond order will be 1.5. 18 electron species, you'll find its bond order as 1. Similarly, 13 electron species, you'll find its bond order 2.5. 12 electron species, you'll find its bond order 2. 11 electron species, you'll find its bond order 1.5. And 10 electron species, you'll find its bond order 1. So these are few things which you need to know first of all. Okay? Perfect. For example, I'm asking you to get the bond order of N2, get the bond order of Cn negative, get the bond order of O2 di negative, okay? Get the bond order of N2 positive. You can easily do it now. You just have to check how many electrons are there in N2, how many electrons are here, how many electrons are here, how many electrons are here. Let's check that out first. My dear students, N2, one nitrogen atom has got 7 electrons. So 2 will have 14 electrons. So it's a 14 electron species. Similarly, 7 plus 6 is 13. 13 plus 1 is 14. It's again a 14 electron species. O2 di negative, 18 electron species. N2 positive, 13 electron species. Now you know, 14 electron species will have bond order of 3. 14 electron species will have bond order of 3. 18 electron species has got the bond order of 1. 13 electron species has got the bond order of what? 2.5. 2.5. Okay. This is how you arrange them on the basis of bond order. Now you can arrange them on the basis of bond length as well. Right? More the bond order, lesser the bond length. More the bond order, lesser the bond length. You know that already. Okay. Now there is one more thing which you need to know. My dear students, remember when you talk about the isoelectronic species. When you talk about the isoelectronic species, what are isoelectronic species? Isoelectronic species are the ones which have got same number of electrons. Remember isoelectronic species, you will find their bond order same. For example, N2 and Cn negative. They have got equal electrons, so they are isoelectronic. Their bond order will be same. Okay? Their bond order will be same. Am I clear? Am I clear, people? Everyone in the chats? Am I clear? Quickly, let me know in the chats, people. Quickly, let me know in the chats. Is this particular point clear? Remember, there is a species CO positive. This is the only exception in this particular thing which I'm giving you right now. CO positive. Okay? CO positive. Carbon has got 4 valence electrons. Oxygen has got 6 valence electrons. Right? Since we are not talking about the valence electrons, we have to calculate the total electrons. Carbon has got 6 electrons. Oxygen has got 8 electrons. There is positive charge, subtract 1. So 8, 6, 14, 1, 13. So it is a 13 electron species. If it is a 13 electron species, its bond order should be 2.5. But remember, its bond order is 3.5. Its bond order is 3.5. Remember it directly as the exception. Okay? Remember it directly as the exception. Perfect? Am I clear? Am I clear, people? So this was the concept number 5, which is frequently. Now, how do you check whether the substance is oxidizing agent or reducing agent? Again, one more question which is frequently asked. How do we check whether the substance is the oxidizing agent or reducing agent? This is something very important. So try to understand what exactly I'm going to say and utilize it in the question. My dear students, for example, I'm writing a reaction. The reaction is simple like this. MnO4 negative plus Fe di positive. It gives Mn di positive. And with Mn di positive, what do we have? We have got Fe tri positive as well. Let's say this is the reaction. I want to know, first of all, which one is your oxidizing agent? Which one is your reducing agent? I want to know that first. My dear students, what is the oxidation state of manganese here? When you calculate the oxidation state of manganese, how do you do it? Let the oxidation state of manganese is X. Oxygen will show -2 oxygen state. There are 4 oxygen atoms. Net charge is -1. When you solve it, the value of X comes out to be +7. So basically, manganese here is in +7 oxidation. Okay. Similarly, iron here is in +2 oxidation state. Similarly, manganese here is in +2. Here, iron is in +3. Now, if I ask you, is the oxidation state of manganese increasing or decreasing? Is the oxidation state of manganese increasing or decreasing? +7 to +2. +7 to +2. Decrease in the oxidation state. +7 to +2. Decrease. Decrease in the oxidation state is what you call as a reduction. Decrease in the oxidation state is what you call as reduction. And remember, the one that undergoes reduction will be your oxidizing agent. The one that undergoes reduction will be your oxidizing agent. Similarly, +2 to +3. Increase in the oxidation state. Increase in the oxidation state is something which you call as oxidation. Increase in the oxidation state is something which you call as oxidation. And the one that undergoes oxidation, that will be always your reducing agent. That will be always your reducing agent. I believe this is also clear to everyone. For example, if I take a reaction like this, Cr2O7 dinegative plus C2O4 dinegative, it gives Cr tripositive. With that, you are writing carbon dioxide as well. Now, what am I supposed to do first? I need to calculate the oxidation state. When you calculate the oxidation state of chromium here, it becomes +6. Oxidation state of carbon here will be +3. This chromium +3. This carbon, when you calculate, it will be +4. And I hope you know how do we calculate the oxidation state. Now, my dear students, tell me one thing. +6 to +3. +6 to +3. Decrease in oxidation state. Decrease is something which you call as reduction. Reduction means oxidizing agent. +3 to +4. +3 to +4. Increase in the oxidation state. Increase in the oxidation state is called as oxidation. And oxidation means reducing agent. So this is how you identify your oxidizing agents and reducing agents if the reaction is given. Okay. Now comes a point. For example, I'm not writing any reaction. I'm just writing HCl. I'm asking you whether this HCl is going to behave like oxidizing agent, reducing agent, or both. Okay. For example, I'm writing H2S. I'm asking you whether it's going to behave like oxidizing agent, reducing agent, or both. For example, I'm writing K2Cr2O7. I'm not writing any reaction. I'm just asking you whether this is going to behave like oxidizing agent, reducing agent, or both. How do we check? Without giving the reaction. If the reaction is not given, you're just given with the compound and they are asking you whether the compound is going to behave like the oxidizing agent, reducing agent, or both. How do we do that? Understand and remember a few things for that. My dear students, when you talk about your P block elements, your P block elements, they show variable oxidation state. You know, your P block elements, what do they show? They show the variable oxidation state. They show the range of oxidation state. Your P block elements, they show the range of oxidation state. Now, remember one thing. What is the range of the oxidation states which P block elements show? The range of the oxidation states shown by P block elements is from group number -18 group number minus 18 till group number minus 10. Group number minus 18 till group number minus 10. For example, talk about chlorine. Talk about chlorine. Chlorine is a p block element. Talk about sulfur. Sulfur is a p block element. Talk about phosphorus, p block element. Now tell me, what is the group number of chlorine? If I ask you about the group number of chlorine, that's 17. Right? If I ask you about the group number of sulfur is 16. If I talk about the group number of phosphorus, that is 15. That is 15. And remember, p block elements. These are your p block elements, first of all. Now, if they are your p block elements, they are going to show the range of oxidation states. They are going to show the range of oxidation states. How exactly? Let me tell you, oxidation state range here will be group number minus 18. Group number is 17. 17 minus 18 is minus 1. 17 minus 10 is plus 7. This is the range of the oxidation states which chlorine can show. Similarly, in case of sulfur, group number is 16. 16 minus 18 is minus 2. 16 minus 10 is plus 6. Right? Similarly, 15. 15 minus 18 is minus 3. Right? And then 15 minus 10 is plus 5. Perfect. So I would say this is the lowest possible oxidation state of chlorine. This is the highest possible oxidation state of chlorine. Lowest possible oxidation state of sulfur, highest possible oxidation state of sulfur. Lowest possible oxidation state of phosphorus, highest possible oxidation state of phosphorus. Right? And remember, your chromium and manganese, they are your D block elements. Chromium and manganese, they are your D block elements. But remember their maximum oxidation state. Chromium shows the highest oxidation state of plus 6 and manganese shows highest oxidation state of plus 7. Remember these two things as well. Why am I telling you to remember all this? Because there is a logic behind that. What is the logic? Try to understand. My dear students, as I'm telling you, if you are given with the compound and you are supposed to check whether the compound is going to behave like oxidizing agent, reducing agent or both, what you are supposed to do? One simple thing. Calculate the oxidation state of the central atom. Calculate the oxidation state of the central atom. This is the first thing. I'll show you how it's applied in the form of questions in some time. Try to remember what I'm going to tell first. My dear students, calculate the oxidation state of the central atom. After calculating the oxidation state of central atom, remember, if the central atom is already present in lowest possible oxidation state, after you calculate the oxidation state of central atom, then if the central atom is already present in lowest oxidation state, can it further decrease the oxidation state? Since it's already present in lowest, it cannot further decrease its oxidation state. But it can increase its oxidation state. And when it increases the oxidation state, it will undergo oxidation. And when it undergoes oxidation, it is going to behave like the reducing agent. So when you see the central atom in lowest oxidation state, it is going to behave like the reducing agent. Okay. My dear students, if the central atom is already present in highest possible oxidation state, can it further increase the oxidation state? No, because it's already present in highest. It cannot increase, but it can decrease its oxidation state. When it decreases the oxidation state, it will undergo reduction. Because decrease in oxidation state is called as reduction, right? It will undergo reduction. And the one that undergoes reduction behaves like the oxidizing agent. So here, it's going to behave like the oxidizing. Okay. Now, similarly, if the central atom is present in its intermediate oxidation state. If the central atom is present in its intermediate oxidation state, that means neither lowest nor highest. If the central atom is present neither in lowest oxidation state nor in highest oxidation state, intermediate, in middle, it can increase also, it can decrease also. That means it is going to behave like, it can behave like oxidizing agent as well as reducing agent. It can behave like oxidizing agent as well as reducing agent. Let me take certain examples. With that, your things will be clear. For example, I am writing H3PO5 or H3PO4. Tell me whether it's going to behave like oxidizing agent, reducing agent, or both. I'm asking you. Someone is asking, what does TC mean? TC means take care. Wow. Quickly, people. H3PO4. First of all, I'll be calculating the oxidation state of phosphorus. When you calculate the oxidation state of phosphorus, that will be +5. Now, what is the range of oxidation state that phosphorus shows? Phosphorus shows the oxidation state from -3 to +5. -3 to +5. Right? Phosphorus shows from -3 to +5. So +5 is already the highest oxidation state of phosphorus. +5 is already the highest oxidation state of phosphorus. And if phosphorus is present in highest oxidation state, this compound is going to behave like the oxidizing agent. Simple. Right? Perfect. For example, I'm writing ClO4 negative. ClO4 negative. Tell me if it can behave like oxidizing agent, reducing agent, or both. Quickly. Quickly, people. ClO4 negative. What do you think? ClO4 negative. Now, first of all, when you calculate the oxidation state of chlorine here, it is going to be +7. Now, chlorine, the highest oxidation state of chlorine is already +7. We have seen that a few minutes back, right? Chlorine is the highest oxidation state, so it's going to behave like the oxidizing agent. For example, H2S. H2S. Tell me, is it going to behave like oxidizing agent or reducing agent or both? Calculate the oxidation state of sulfur. It will be -2. -2 is the lowest oxidation state of sulfur. So sulfur is present in lowest oxidation state. So it's going to behave like the reducing agent. For example, you have got H2O2, hydrogen peroxide. Oxygen has got -1. -1 is the intermediate oxidation state of oxygen, right? So it's going to behave like both oxidizing agent as well as reducing agent. So this is how you are going to identify whether the given substance is your oxidizing agent, reducing agent, or both. If this is clear, let me know once in the chats quickly. Let me know once in the chats quickly, people, if all of this is clear to everyone. Everyone in the chats, quick. Quickly, people. Everyone in the chats, people, quick, everyone. Yeah? Okay. Now, my dear students, till now we are done with. This was our concept number 6. Here comes the concept number 7. Concept number 7. What is that? That is going to be strength of oxidizing agent. Sometimes they'll ask you to give the order of the strength of oxidizing agent. Remember, whenever they'll give you 3-4 oxidizing agents and you're supposed to arrange them on the basis of their strengths, remember one simple thing. Strength of oxidizing agent is directly proportional to the oxidation state of central atom. Strength of oxidizing agent is directly proportional to oxidation state of central atom. Number one. Number two, sometimes they'll give the question on the basis of strength of reducing agent. Remember, strength of reducing agent is inversely proportional to oxidation state of central atom. Sometimes they'll give the question on the basis of acidic strength. Generally, you will observe acidic strength is directly proportional to oxidation state of central atom. Similarly, sometimes they'll ask you the question based on basic strength, right? That is inversely proportional to oxidation states of central atom. I'm talking in general sense. All right? You can get the questions based on this as well. For example, I'm writing KMnO4. I'm writing K2Cr2O7. I'm asking you, which one is the stronger oxidizing agent? KMnO4 or K2Cr2O7? Quickly. KMnO4 or K2Cr2O7? Quickly. Which one is the strongest oxidizing agent? KMnO4 or K2Cr2O7? I'm asking you. Everyone. Everyone, people, in the chats. Quick, quick, quick. Are we done? Are we done? Are we done? Absolutely, guys. This manganese here is in +7 oxidation state when you calculate. Chromium here will be in +6 oxidation state. When you calculate more the oxidation state of central atom, more is going to be the strength of the oxidizing. Okay. Tell me, if I write NH3 and H2S, NH3 and H2S, here you gave the order of strength of oxidizing agent. Give me the order of strength of reducing agent. Which one is stronger reducing agent here? Quick. Which one is stronger reducing agent among these two? Everyone. Everyone in the chats. Everyone in the chats. Wait, guys, this should not take this much of time. It should not take this much of time. Done? Done? So here the oxidation state of nitrogen is -3, here it's -2. And you know, lesser the oxidation state of central atom, lesser the oxidation state of central atom, more is going to be the strength of reducing agent. So NH3 is going to be stronger reducing agent than that of H2. Perfect. Now, my dear students, comes one more concept. That's concept number 8. Eighth concept. Eighth concept. Balancing of redox reaction. How do we exactly balance the redox reaction? Simple method I'm going to give you, by means of which you are going to balance the redox reaction. Simple method. Understand. For example, I'm writing a reaction, a simple reaction like this. MnO4 negative plus Fe di positive. Let's say it gives Mn di positive, and with Mn di positive, you are writing Fe tri positive. Let's say this is the reaction. And you are supposed to balance this reaction in acidic medium. You are supposed to balance this reaction in acidic medium. Okay? Sir, could you teach limiting reagent? In the yesterday's session, I have taught limiting reagent. Check that out. How to balance this particular reaction in which medium? In acidic medium. Okay? Now understand what exactly I'm going to say. My dear students, the first thing, what is the oxidation state of manganese here? When you calculate +7. Oxidation state of iron here, +2. Oxidation state of manganese here, +2. Oxidation state of iron here, +3. Okay? Now, what is the change in the oxidation state of manganese? +7 to +2. +7 to +2. Change is final minus initial. The value comes out to be 5. Value comes out to be 5. Right? So the change for this particular species is 5. +2 to +3. +2 to +3. What is the change? Final minus initial. Value is 1. The value is 1. Okay? Now you got the change in the oxidation state. After getting the change in the oxidation states, do one thing, just crisscross them. Crisscross them means this 1 becomes the stoichiometric coefficient here, this 5 becomes the stoichiometric coefficient here. So crisscross. After crisscrossing, first I got the change in the oxidation state, then I crisscross them. After crisscrossing, balance all the atoms except hydrogen and oxygen. Balance all the atoms except hydrogen and oxygen. Now tell me, leave hydrogen and oxygen aside. Tell me how many manganese do you see here? 1. So there is 1 manganese. How many iron atoms do you see here? 5. So there are 5 iron atoms. Okay. Now after doing this, balance oxygen with the help of water molecules. Balance oxygen with the help of water molecules. How many oxygens do you see here? 4. On this side, there is no oxygen. So this side is oxygen deficient. This side is oxygen deficient. How many oxygen deficiencies? 4. So add 4 water molecules on that side, which is oxygen deficient. Now, after balancing oxygen, balance hydrogen with the help of H positives. Do you see any hydrogen here? No. Do you see any hydrogen here? Yes. How many? 4 2s are 8. 8 hydrogen on this side. No hydrogen on this side. So add 8 H positives on this particular side. The reaction is balanced now. The reaction is balanced now. Is this particular point clear to everyone? Let me know once in the chats, quick. Quickly, people, everyone in the chats. Quickly, quickly, quickly. Everyone in the chats, quickly. Yes. Perfect, guys. I'm giving you one more reaction. Now you should be in a position to balance the reaction on your own. Okay? You should be in a position to balance the reaction on your own. For example, the reaction is like this. Cr2O7 di negative plus Sn di positive. Sn di positive. It gives me what? It gives me Cr tri positive plus Sn plus 4. I am asking you to balance this particular reaction in acidic medium. Now, it should not take more than 20 seconds to do it. It should not take more than 20 seconds, people. Kill it quickly. Quickly, my dear students, everyone. See what you're supposed to do. First of all, get the oxidation states. If you talk about the oxidation state of chromium here, it comes out to be +6. This tin here will be in +2 oxidation state. This chromium here will be in +3 oxidation state. And this tin here will be in +4 oxidation state. Now tell me one thing. +6 to +3. +6 to +3. What is the change? Final minus initial. The value is 3. 3 is the change for one atom. I have 2. So 3 2s are 6. The change is 6 here. The change is 6 here. Why? Because we have got 2 chromium atoms. Similarly, my dear students, +2 to +4. +2 to +4. What is the change? Final minus initial. The value is 2. 2 is the change for 1. I have only 1. So it's changes 2 here. Now, after getting the change in the oxidation state, what am I supposed to do? I'm supposed to crisscross them. This 2 goes the stoichiometric coefficient here. This 6 goes the stoichiometric coefficient here. Right? Now, my dear students, after doing the crisscross stuff, balance all the atoms except hydrogen oxygen. Balance all the atoms except hydrogen oxygen. So this 2, balance all the atoms except hydrogen oxygen. So we have got 4 chromium on this side, 4 chromium on this side. We have got 6 tin on this side, 6 tin on this side. Okay? Now, balance oxygen with the help of water molecules. So how many oxygen atoms on this side? 7 2s are 14. Do you see any oxygen here? No. So I'm going to add 14 water molecules on this particular side. 14 water molecules on this particular side. Right? That side which is oxygen deficient. Now talk about hydrogen. No hydrogen on this side. How many on this side? 14 to 28. Right? So add 28 H positives on that particular side, which is hydrogen deficient. So the reaction is balanced. If I'm clear, let me know once the chat's quick. Did you understand how do we balance the reactions? And you are asked only the reactions in acidic medium. They don't ask you the reactions in basic medium. So don't worry. Quickly, people. Quickly in the chats. Quickly in the chats. Yeah? Perfect. There are 3 Sn di positive. Why 3 Sn di positive? Its change was 6 for 2 atoms. So 6 here. Okay? I believe every stuff is clear till here. I believe every stuff is clear till here. Now, my dear students, this was concept number 8. Moving on to concept number 9. Heat and work. Heat and work. Okay? Heat and work. This is the topic which is from the chapter thermodynamics. Now you just have to remember few things here and we are done. That today I scored 170 out of 180 in my mock test by just seeing your videos alone and revising multiple times. Great. Keep doing. Keep doing. So first of all, heat and work, my dear students. What kind of questions can be asked from here? What kind of questions can be asked? And what all things we have to remember first of all? Just remember few points first of all. Remember, my dear students, whenever system absorbs heat, whenever system absorbs heat, whenever gas absorbs heat, remember Q value is taken as positive. Remember Q value. Q represents heat. Q is taken as positive as per sign convention. Okay. Similarly, whenever system releases heat, my dear students, whenever system releases heat, Q value is taken as negative. These are the two things which you need to remember first of all. Okay. Similarly, few more things. Whenever volume of the system increases, whenever the gas undergoes expansion, we always say work is done by the gas. And whenever work is done by the gas, in chemistry, W value is taken as negative. Similarly, my dear students, whenever there is compression means when the gas undergoes decrease in volume, when the volume of gas decreases. That's something we call as compression. Whenever there is compression, we always say work is done on the gas. And whenever work is done on the gas, W value is taken as positive, as per sign conventions in chemistry. These are few things which you are supposed to remember. And how do you calculate W here? W is generally calculated like this. Minus P external into delta V. Particularly when you talk about irreversible process. I'm not talking about that in detail. Just remember these few things and you'll be in a position to solve the questions. See what kind of questions can be framed. Look at this question. In all these processes, you have to check whether work is done by the system or work is done on the system. In all these processes, you have to check whether work is done by the system or on the system. In all these things. So what you'll be doing? My dear students, if you look at the first case, the reaction is 4 times NH3 gas, plus 7 times O2 gas. It gives 4 times NO2 gas, and with that you are writing 6 times H2O gas. Right? Perfect. My dear students, the reaction is carried out at STP. So in short, I would say, when the reaction is carried out, pressure and temperature is kept constant. Do you know about your ideal gas equation? I believe yes. PV is equal to nRT. Now pressure and temperature is kept constant. R value is already constant. So volume and moles, they are directly proportional. Now tell me one thing. How many moles do you see? How many gaseous moles do you see on the reactant side? 7 plus 4 is 11. 6 plus 4 is 10. Gaseous moles on reactant side, 11. Gaseous moles on product side, 10. Tell me one thing. As the reaction proceeds, are the gaseous moles increasing or decreasing? As the reaction proceeds, are the gaseous moles increasing or decreasing? Gaseous moles are decreasing. If moles are decreasing, volume will be decreasing. Decrease in the volume is what you call as compression. Whenever there is compression, work is done on the gas. So in the first case, work is done on the gas, and when work is done on the gas, W value in chemistry is taken as positive. Right? Perfect, guys. Perfectly done. Quickly. Look at the second question, people. This was question number 1. If I talk about this second question, the second question is like this. Carbon monoxide gas plus 2 times H2 gas, it gives me what? It gives me CH3OH liquid. Right? This is the reaction. I need to check whether work is done by the gas or on the gas, whether work is done by the system or on the system. So what you will be doing, understand, since all the reactants products are not in gaseous phase, so I'm not going to use this approach. What approach I'll be using? I'll be using common sense. What is my common sense saying? My common sense is saying that on reactant side, you have got gas. On product side, you have got liquid. So gases are getting converted into liquid. When gases will be getting converted into liquid, I would say molecules will be coming closer. Gas is getting converted into liquid. Molecules are coming closer. When molecules are coming closer, volume would be decreasing. Decrease in the volume is what you call as compression. Whenever there is compression, work is done on the system. So again, work is done on the system. W value taken as positive. Okay. Leave the third case aside. Talk about the fourth case first. You have got H2O solid. Solid is getting converted into gas. If solid is getting converted into gas, that is directly the case of expansion. Work is done by the gas. Right? Work is done by the gas. W value is taken as negative. Perfect? Right? Yes, Yuvanish, because these patterns are repeated every year. These are the standard questions. That's why I'm showing these standard questions. Perfect? Now, if you look at this particular case, H2O solid gives H2O liquid. H2O solid gives H2O liquid. So solid is getting converted into liquid, right? Solid is getting converted into liquid. What should be the answer? When solid gets converted into liquid, so technically volume should increase. Increase in the volume is what you call as expansion. Whenever there is expansion, work is done by the system. W value is taken as negative. But in case of water, things are different. What things are different? In case of water, my dear students, this is ice. Ice is getting converted into liquid, right? Remember, ice has got more volume and liquid water has got lesser volume. Due to the special structure of ice, its volume would be more than that of liquid water. Okay? This is a special case. Remember, ice has got more volume, liquid water has got lesser volume. So more volume to lesser volume. So decrease in the volume. Decrease in the volume is what you call as compression. Whenever there is compression, work is done on the system, right? Work is done on the system. And whenever work is done on the system, W value is taken as positive. Am I clear? These sort of questions are again frequently asked in the exam. Clear, guys? Clear. Say it in the chats quickly. Now the 10th concept, my dear students, which I'll be discussing with you, what is that? That is the relation between delta H and delta U. Again, a frequently asked question. A relation between delta H and delta U. So what I'll be doing? Remember, the direct result between delta H and delta U is like this. Delta H is equal to delta U plus delta of PV. This is a direct result. A general result between delta H and delta U. Delta H is equal to delta U plus delta of PV. Okay. Now, my dear students, remember, if I write the result at constant pressure, it is written like this. Delta H is equal to delta U plus P comes out, it's P delta V. This is the result between delta H and delta U, which is written at constant pressure. If I write the same result at constant volume, the result becomes delta H is equal to delta U plus V comes out, it becomes V delta P. Right? And remember, if pressure and volume both are changing, both are not constant, if pressure and volume both are changing, then the result would be delta H is equal to delta U plus, it's going to be P2 V2 minus P1 V1. This is the result which I'll be using when in the question they'll mention that pressure and volume both are changing. Okay? And my dear students, remember one more thing. For a gaseous phase reaction, which is carried out at constant temperature, which is carried out at constant temperature. Remember, delta H is equal to delta U plus delta NGRT. Delta H is equal to delta U plus delta NGRT. These are few results which, first of all, you are supposed to remember. These are few results which, first of all, you are supposed to remember. Now, my dear students, after remembering these results, what we are supposed to do? What we are supposed to do? Let's try to solve a question so that you'll understand what is going to happen. Look at the question carefully. You have got the gas whose initial pressure is 2 atm, whose initial volume is 3 liters, right? Final pressure is 2 atm and final volume of the gas is 7 liters. So first of all, is the pressure of the gas changing? No, the pressure of the gas is not changing. If the pressure of the gas is not changing, I would say the gas is kept at constant pressure. And when the gas is kept at constant pressure, what result I'll be using between delta H and delta U? Few minutes back I told you, delta H is equal to delta U plus P delta V, right? What is your delta U? Delta U is 30 atm liter. I need to calculate delta H. I need to calculate delta H. So delta H is equal, delta U is 30 plus P is how much? 2. Delta V, change in volume. Final volume minus initial volume. So 7 minus 3 is 4, right? So the value comes out to be 38 atm liter. This is the value of delta H which you were supposed to calculate. Am I clear with this? Am I clear with this, my dear students? Everyone in the chats quickly. Everyone in the chats quickly. Yeah? Done? It is not 38 joules, it's 38 atm liter. It is 38 atm liter. Sir, even KK sir also takes session like you. Of course, he's my elder brother. Okay? He does not take sessions like me. I take sessions like. He has teaching experience of from 2006. 20 years. 20 years that guy has been teaching organic chemistry. Now you can understand. There will be MCQ questions, practice sessions also, don't worry. That is also planned. Sir, are you married? Do you see this? All right, should we move on? Should we move on? One question I'm giving you as the homework on the same topic, right? Do let me know its answer in the comment section of this particular. So guys, we are done with 10 concepts. I think this much is enough for today. There'll be part 3 also that I told you. So till now we are done with how many concepts? Yesterday's session 12 concepts, today 10 more concepts. So we are done with 22 concepts. So there'll be part 3 coming. In part 3, we'll complete the rest of the topics, right? Of our physical and inorganic. Whereas organic sessions, organic class will be taken by your KK sir, right? The top 10 to 15 concepts of organic chemistry he'll be taking. My part is physical and inorganic, right? I think I'm left with almost like 15 to 20 more concepts, which I'll be taking in the next session, right? And organic 10, 15 concepts will be taken by this KK sir, right? Sir, what is my experience of teaching? My experience of teaching is 8-9 years. I'm not that old. I look old, yeah. I'm 30. Okay. When I was 22, I started teaching. Right after my college. Basically, in the college also I was teaching. Like when I was doing my engineering, during the engineering, I used to teach mathematics to the engineering students. Basically, when I was in my third semester, I used to teach the second semester student the mathematics, the maths. Then when I was in fourth semester, I used to teach third semester student, like that. So that's how my teaching career started. And when I was done with my engineering, after that, I started teaching chemistry. For 6 to 7 months, I've taught physics as well. For 6 to 7 months. That too in Chennai. Chalo. Guys, paper won't get leaked. Don't worry. Don't worry. Just erase this thought from your mind now. Please. Okay? Chalo. I'll be sharing the PDF of this particular session in the Telegram channel. Okay? Perfect. And the ones who have not liked the session yet, do smash the like. And once the session ends, do let me know in the comment section whether you want more such kind of the sessions or not, whether these sessions are beneficial for you or not. Of course, these sessions are beneficial. That's the reason why we are coming up with these sort of sessions, right? But I would want you guys to let me know in the comment section. Yeah? Chalo, guys. Take care. God bless you all. And